Let us look at the LeetCode problem 329, longest increasing path in a matrix. We are given an m by n integer matrix and we have to return longest increasing path in the matrix. So when we mean increasing path, you can see here, right? For example, I could have an increasing path 6, 9, okay? Or like 1, 6, 9, or maybe like 1, 6, 8, 4, things like that. So, and we have to find the longest of such paths. So that's the background. In each element, we can move. We have 4 degrees of freedom. We can either move to the left, right, top, or bottom. The moment you see this, it look like such problems, like mostly it will have something to do with the DFS. So now let's take the brute force approach and see how to solve this problem. Let's assume that we go through each point and do a DFS and find the length of each of the paths. So then that means, let's take for example 9. Starting from 9, if I try to move left, you can see, right, this cannot be done because 9 is already equal, so it doesn't form an increasing series. Now if I try to move up, that's an invalid location. I try to move left, invalid location. I try to move down, it's lesser, so this is also not possible. So from at this point, 1 is maximum that I can do. Similarly, when I try here, you can see it's same. 9 will only be 1, and this continues. Now let's take some cases here, right? So at this point, when I come again, you can see 6 you can have 2 elements. The reason is I cannot go to the left, but I can go up. So then that means starting at 6, I will have a array length of 2 because I can go to 9. So same here, if I go here, I can go either up or I could go this way. So in both cases, I'll get of length 2. Okay, that will be my max. And now if you see, come here again, assume that we just like that we iterate to this point. Okay, here also if you see here, we will go up, which will be from here 1. So it can go to 6, and from 6 it can go to 9. So if you see here, this will be 3. Okay, and from 1 again this entire path is tracked, so that means this will be 4, and so on. But now if you see, if we do a normal DFS, in each point I have 4 options, and my length on each of these paths could be maximum of mn. So the time complexity will be order of mn into 4 raised to mn, because I try it on each location. So that is, the entire parsing is mn to n, and then at each point I could have 4 raised to mn because I have 4 options, and space complexity is order of mn. This is not feasible. But now if you think, see here on whatever I have written, let's take this example 6, right? So if we had cached this value at that point, then when we come to 2 and when we try to go to 6, we don't have to parse it any further, because if we cache this value, then we can just reuse that value for this calculating this path of this length. And same way, when we come to 1 and we move this way, we don't need to go through this entire path. Instead, we can cache the value of 2, so that for this path it's just like 1 plus 3. So if you do it that way using caching, that will bring our time complexity to order of mn, because at each point we'll just cache and keep moving forward, and the space complexity will be order of mn. So now let's code this up. We will iterate through each element in the array and see what is the length of the maximum path. Let me first do a DFS solution, and then I'll convert it to caching. Int c is equal to 0, c less than matrix 0 dot size plus c. Okay, there is one more thing that I missed to mention earlier. We need the previous value to ensure that the current path that we are doing a DFS is in the increasing order. Okay, so let me show you here. So we will do, let me put this as our current length. okay, is equal to underscore DFS. Okay, I'll just pass -1 here because the values are mentioned to be in the range of 0 and higher. So to start with, I'm just putting -1, and we will start with R comma C and matrix. Okay, and we can also keep track of the max length equal to 0 here, and we'll just put max length is equal to max of curl length and max length. That's it, and we will return the max length. Okay, now let's write our DFS function. I will explain why we need the previous value when I write my DFS function. So here value. Okay, that's the first argument, int R, int C, and this is our matrix. Okay, now if you see here, first is we have to see whether because we have 4 degrees of freedom, so we have to validate the index. So we can just put a generic row column validation is equal to R greater than or equal to 0 and R less than matrix dot size. Okay, then we will do a C inbound check, which is the column check. So 0 dot. Okay, so we will just check for not R inbound. Let's put it bounds. And or not C inbounds, then that means there is no path in this direction, so I'll return 0. Okay, now the next case is if pre value is, so it has to be an increasing order, right? So if matrix RC is less than or equal to previous value, then also we can return 0. Okay, because then there is no point in continuing in this path. I'll just combine it here just for keeping it concise. You can keep it the other way also. Just to keep it concise, I'm just moving it up. Now what we'll do is we will we have 4 degrees of freedom, and my max length will be 1 plus, I have to introduce also consider the current element, and it will be and we will pass the current element as our previous element for checking the next element in our 4 degrees of freedom. So check in 4 degrees of freedom. Okay, so if you see here, this will be I will just pass, so I could have R plus 1 C matrix, yeah, then I could have equal to max of, it will be max length, this will be R minus 1. You could even write this in a loop, a direction loop. I'm just keeping it simple because only 4 degrees of freedom are there, so I'm just hard coding it here, but feel free to put it in a loop format also. So this is what we will have, and we can just return the max length. So let's see if this something is wrong. Let's see. Yeah, that's a basis. So Shoot. So now let's see. This should be good, but this will not be accepted because it's, as I mentioned earlier, the time complexity will be m into n into 4 raised to m into n. Now let's see how to do the caching here. So what we'll do is we need to cache it at each element of the matrix. Okay, so we'll just do vector int dp size, comma, vector int, just make it a little bit smaller. Okay, this will be matrix of 0 dot size, comma, -1. Okay. Now we'll also pass the dp here. We vector so we have to pass the dp here. So we'll check if dp of rc, I would just keep it as 0 because I think if it is visited, at least the value will be 1 because at least the series will contain that element alone. So we just return dp of rc. Okay. And what we'll do is we will just store dp of rc is equal to max length, dp. We have to just pass that dp also along. Now let's see. Oops, sorry, missed here. So let's see. So we took this one, matrix dot size, matrix 0 dot size, -1 rc matrix. So we came here, this is not equal to 0. Oh shoot, I should have put it below. Okay, so this looks good. Thank you. Have a good one.